Welcome back to AgriNova and to the series of Soil Science Part 2. So, in Part 1, we have seen that about what is soil, its components, then rocks, its types like igneous, metamorphic, sedimentary rocks. We also have seen about rock cycle, okay? And then we have seen about the weathering processes, the types of weathering, that is physical, chemical, and biological. So, here in the part 2, we are going to see about the soil profile and soil forming processes. How is soil formed? So, let's start with the part 2 series. First, let's see what do you mean by soil profile. So, the definition of soil profile is a vertical section of soil showing various layers. So, this is the vertical section of soil showing various layers from surface to the unaffected, means the bottom part, which is basically a pure rock or parent material. So, vertical section of soil showing various layers from the surface to unaffected part is called soil profile. Mainly, the soil profile is divided into the soil profile is divided into 5 to 6 horizons, mainly O horizon, A horizon, E layer, B subsoil horizon, C horizon, and R, which is the bedrock. So let's see in detail what is the horizon about. So O horizon means basically it is the organic layer. So organic layer, which is means the organic horizon that from above the mineral soil. मतलब ये जो layer है, it is deposited with the plant litter or any undecomposed matter or dead matter. That's why it is called the organic layer, because the organic matter is in the raw form. Basically found in forested areas or grasslands. It is mostly found in forested areas and absent in the grasslands, because majority of the vegetation found in forested land. Then next, the below layer, which is the layer called A horizon, generally present below the O horizon, is called mineral horizon. And basically this layer contains dark color because it contains a mixture of decomposed organic matter. So it tends to have dark color. The next horizon is about E horizon, means basically elevated. So elevated मतलब जो clay and sesquioxides are invariably leached out. मतलब ये जो E layer है, basically the clay particles or the sesquioxides like aluminum oxides, iron oxide, they are basically leached down to the below layers. So it is the horizon of leaching out. So basically it is called elevated horizon. Okay. So both of the clay and sesquioxide minerals leach down, and we know that quartz is highly resistant to leaching out, so it is left over in the layer, and all the minerals leach down to the next horizon. So due to all this, it becomes lighter in color due to washing out of minerals. The next horizon is B horizon. It is also called elevated, means the leaching in. So we know that the clay and sesquioxides minerals leach down to the next layer, so it gets deposited in the B horizon. The process is called elevation or elevation. So it is a process of leaching in. So all these minerals get leached into the below horizon, which is called B horizon. So basically the accumulation of sesquioxides and clay particles or minerals. Basically in the region of arid and semi-arid, calcium carbonate or calcium sulfate and other salts get deposited in the B horizon. So as per the region, various salts or minerals get deposited below the E horizon, which is elevated. So याद कैसे रखना है, अल्फ़ाबेट्स में ई पहले आता है तो ई से एलिवेटेड मतलब जो ऊपर आएगा और आई बाद में जो नीचे आएगा उसे कहते हैं इलिवेटेड. So basically it is leaching in, and the elevated starting from E, it means leaching out. So the next horizon is C horizon. हाँ एक बताना भूल गया, जो B horizon due to the accumulation of the sesquioxides and clay, it gets darker in colors. Okay, the next horizon is mineral horizon or the unconsolidated layer. Material. So basically it is the hard part of layer. You can see in the images that it halfly eroded or less weathered or unweathered. So it's basically beyond major biological activities. This horizon contains larger wide spaces between the rocks or cracks. There is one more horizon called R layer, or which is also called bedrock, which is beneath the C horizon. Basically it is the pure rock structure which has little or no impact of weathering. ओके तो हमने सॉइल प्रोफाइल देख ली. ओ से ऑर्गेनिक लेयर जहाँ लिटर डेड ऑर्गेनिक मैटर प्रेजेंट रहता है, ड्यू टू विच इट गेट्स little darker in color due to presence of humus. So the next layer is mineral rich humus layer where decomposed organic matter is present. Then next the elevated layer where the minerals like sesquioxides, clay and organic matter leach down to the next layer, the layer called elevation, मतलब I से चालू होती है. So it's the process of leaching in, accumulation of sesquioxides and the clay from the upper surface of layers. So the next layer is C layer. It is called unconcentrated layer, less or more chemically weathered or partially weathered. The next it is called unweathered, which which is purely weathered rock. Which is purely unweathered rock. So let's see the soil forming processes. Before going to process, we have to see the two scientists who gave about the factors of soil formation. So first, the Doctor established soil established that the soil developed as a result of the action of soil forming factors. So कौन से factors है? So he mentioned about the factor that is the parent material, P से parent material, the next climate, and the next one is organism. So he mentioned that there are three soil forming factors which basically help in the process of or ease of soil formation. Okay, then the next scientist talks about, that is the Jenny talks about the 5 soil forming factors, that is first climate, organisms, relief, parent material, and time. So it talks about the 5 soil forming factors. Here climate, organism, relief or topography, parent material, and time. So all these factors take place simultaneously at any point on the surface of earth to produce soil or soil formation. So basically these factors are divided into two categories, that is active soil forming factors or passive soil forming factors. So what do you mean by passive soil forming factors? Basically these are the soil forming factors that which represent the source of soil forming mass and condition affecting it. Matlab, the passive soil forming factor provides a base on which the active soil forming factors work. So it basically provides a base or are in static function. So the three passive factors are parent material, relief, and time, PRT. And the next active soil forming factors are climate and vegetation, which may vary on a certain point of time. So let's see about parent material. So basically we have seen in the last lecture what do we mean by parent material. So it is the unconsolidated mass of rock which help in the soil formation. So basically it influence soil texture, and soil texture controls the down movement of water. Okay, so basically the soil forming factor, which is the parent material, can be divided into sedentary and transported. So sedentary means basically it is formed on original place. So it is the residual effect of parent material. So it is weathered and formed on the same place. The next transported means the place of origin. The parent material gets transported from the place of origin through action of gravity, water, and ice. Okay, so for example we can see that how parent material affect the soil forming process, that if the parent material is, example, the basalt rock, it helps in formation of black soil we can see in the region of Deccan. The next example we can talk about, that is if the parent material is acid igneous rock, it leads to formation of light textured podzolic soil. Or we can also give the example of, if the parent material is limestone, we can see the soil having calcareous minerals, or we can say the soil is calcareous soil. Okay, so we have seen about that how parent material affects the soil formation. The next, how relief, or what do you mean by relief and factor affecting in soil formation. So basically, relief and topography are the interchangeable synonym terms, and we can use any one of them. So basically, it means that the elevation of land surface. So we have to see that how elevation affects the soil formation. So basically, there are 3 to 4 components of relief and topography, that is slope, the altitude, which means height, the drainage pattern, the erosion and deposition. So let's see about the slope with examples. So how slope affects the soil formation. So the region of Himalaya having steep slopes increases runoff. Okay, and due to this it reduces the infiltration process of water into the soil. So due to the high runoff and low infiltration, the soil becomes thin, and then it causes erosion of the soil. So basically, due to the steep slope, it causes high runoff. We can see the example of the river Ganga in the Himalayan regions. Basically, the river is in its youthful stage, having high water intensity, causing high runoff and less infiltration, which causes thin soil and more prone to the erosion. Whereas in the gentle slope, we can see in the region of Gangetic Plain, we see more alluvial soil accumulation. So we can see deeper soil layer, which has, we know the soil is better for cultivation, or soil has better fertility. So next, let's talk about the next factor, that is altitude. So basically, at higher altitude, just a minute, I'll take the new color. So basically, at higher altitude, we can see lower temperature, which causes freezing situation or freezing like situation, and it slows weathering processes and slows down the organic decomposition, and makes soil more acidic. So basically, the soil at higher elevation or higher altitude are the soil more acidic. So let's see about the drainage. So well drained soil means basically they have more pore spaces. So More spaces means there is rich oxygen, and we can call it as aerobic situation. So it better for plant growth. Whereas in poorly drained soil, we see the situation that is anaerobic situation, which we can call waterlogging conditions. And the soil becomes glaying or grayish, or it can have blue green color due to various algae. So next, how soil and deposition affects soil formation. So erosion, basically erosion means the removal of top layer or topsoil. So basically it loses fertility and nutrients, and the soil becomes thin and sandy due to the erosion. And due to the deposition, so the eroded soil get deposited in some of the other area and get transported. So deposited soil, here it gets formation of new layer of soil. So the soil is totally fertile. We can see in the region of Ganga plains or Brahmaputra plains. Which is called floodplains. Okay, so we have seen that the how relief and its component affect the soil formation. So basically we have seen the slope, the steep slope having high runoff, less water infiltration causes soil thinning and enhances erosion. The next, altitude, how altitude at the higher altitude and lower temperature it causes freezing of soil and makes the process of weathering slow, and also the decomposition. So it makes the soil acidic. And how drainage, so in the areas of well drained soil it has more oxygen or aerobic condition, it is better for plant growth. Whereas in poor drainage soil, the anaerobic condition or the waterlogging conditions, it causes glaying or grayish blue green algae growth which lacks oxygen. The next, in the erosion and deposition, basically in the erosion it means the removal of top layer, the top fertile layer and nutrients are removed, which makes the soil thin and sandy. And after erosion it comes deposition, the eroded material get deposited in the area. So here in that area it gets the formation of new layer which is more fertile. We can see in the region of Ganga and Brahmaputra floodplains. So next factor is, we have seen the parent material, relief, and the next is time. So basically the time is divided into three types. So how soil formation is affected by time. Basically the young soil, mature soil, the old soil. The young soils are called entisols or inceptisols. We know that the rivers are in young stage, it carries more sediments or soil particles. Basically these young soils are found in the river or flood plains. We have seen the flood plain of Brahmaputra and Ganga, which are recently formed and has weak horizon because they are continuously in the phase of transportation. The next, mature soil. Basically these are the below layers, that is A, B, C horizon. We can see in the region of Deccan, which is black soil, which is deposited and has been from years. The next is old soil, which means highly weathered. We can see features like deep, strongly leached, poor nutrient. Example, lateritic soil and lateritic soils of Western Ghats, the red soils of Tamil Nadu. So basically these are old soils which are highly weathered, which are deep in formation and highly leached of poor nutrient. So we have seen the passive soil forming factors. Let's see active soil forming factors. So active soil forming factors, first it is the climate. So in climate we can differentiate into precipitation and temperature. So in precipitation means basically the rainfall, that is heavy. In the region of heavy rainfall, it causes, we know, due to the heavy rain or water pour down, it causes leaching and makes the soil acidic and nutrient poor. So basically the lateritic soils of Tamil Nadu. And also we can call the soil as podzol. The next, in the region of low rainfall, it causes accumulation of salts, and basically the soil is poor in leaching due to the less water availability. So for this soil we can add gypsum to overcome the problematic soil. So ये हम बाद में देखेंगे, सेपरेट चैप्टर है प्रॉब्लमेटिक सॉइल्स एंड इट्स रिक्लेमेशन. सो बेसिकली लो रेनफॉल एरियाज में क्या होता है, पोअर लीचिंग because of less water and high evaporation and accumulation of salts, or you can say the salts get on the surface of soil due to capillary action. So next, the factor is temperature. In the region of high temperature, it causes the rapid chemical weathering and faster organic matter decomposition. We know in the high temperature condition, the microbial action is in the rapid stage. So it causes rapid chemical weathering and faster organic matter decomposition. So in the lower temperature, it's just opposite, that is slow weathering, organic matter accumulates. Here we can see the example that pit soil in cold region, where the organic matter decomposition is slow. The next we have done with the climate. The next it is organism and vegetation. So basically organism means that is the animals, microorganisms, man or humans. So microorganisms include bacteria, fungi, which decomposes the organic matter and leads to formation of humus. The next, the animals, the earthworm or the termite or ants helps in mixing of soil, which improves the aeration, drainage and improves the structure of the soil. So basically it helps in soil formation, making soil more aerated, helps in drainage process and makes the structure good. The next, how humans through agriculture, deforestation, irrigation, fertilizer application accelerate the formation of soil process. So we have seen in the part 1 video, I am not explaining this in detail. So next, the plant means through root, the root breakdowns the rocks through physical weathering. I have shown this and explain with the image. The next, the plant also helps in adding of organic matter like litter and also influence soil acidity. For example, root release organic acids like citric acid, oxalic acid, malic acid. So this acid helps in dissolving of minerals when in presence of water. So these minerals get dissolved and the pH is maintained, which leads to soil formation. So here for today, I will not make the lecture too lengthy, just keep it in series. So meet you in the next lecture. Do subscribe and like the video.